This is towards Dr. Gates. I'm curious about your theory. You say there's computer code in these equations. Now, computer code is generally just instructions for a processor. And I'm curious as to what the instructions you're finding are. And if you're not sure what's to say that it's actually computer code, I mean, theoretically, the number pi has all the data that's ever existed.
Well, we say that they're computer codes.
You mean the digits in pi?
Yes.
Yes.
Okay. We say they're computer codes, first of all, because the structure of the equation is such that they dictate that there are certain things that are actually strings of ones and zeros. That's just digital data. But it's not just random ones and zeros. As I mentioned earlier, let me talk about something that you probably do every day, but I don't know if you're a computer scientist or not. Most of us sit at our...
Sounds that kind of fluency, I said.
Okay, well, most of us sit at our computer screens and we type on the keyboards, and we then send these, if we're using a browser, we're sending strings of ones and zeros elsewhere. But on the other hand, in the transmission process, there's always some fluctuations. So 0 that you type here because of static in line might be read as a 1 at the other end and vice versa. And so in fact, when you sit and type on the keyboard, your computer's doing something behind your back. Namely, it throws in a bunch of extra ones and zeros, and these things are called error correcting codes, so that the computer at the other end can look at the whole collection of what you typed plus what was sent and figure out if there were bits that were being flipped back and forth. And that's how you get accurate transmission of digital data. Among the codes that are used for this purpose are a special class of codes that are called block linear self-dual error correcting codes. They were first, in fact, the Shannon extended checksum code is an example of one of these things. These are the codes that we find buried in the equations. Not just any code, but these self-dual error correcting block codes. It's quite remarkable for anyone that I've talked to. We have no idea what these things are doing there.
Any literature out?
I'm sorry?
Do you have any literature out that...
I can give you technical references that almost nobody in the world can understand.
But Jim, I thought you had a popular level article on this?
Thank you. Yes, actually, so this past June, the British journal Physics World asked me to write a popular level description of what we have found. So in the June edition of Physics World, and it's published in London, the cover story is called Symbols of Power. It's about these weird symbols that have been showing behind us. We call these things adinkras. And so for a popular level description, yes, we've written that. But other than this one popular level description, it's all technical gobbledygook. And that's a technical term, by the way.
Gobbledygook.
Thank you.
Okay, I'm sorry, we're only going to have time for 2 more questions. I've just been queued, but you'll be one of them, so come on up to the microphone, sure.
Okay, yeah, hopefully this isn't like overly stupid question or uninformed, but I'm just curious whether...
I bet it's not. I'm going to bet you, yeah.
Thank you, but I'm wondering whether like the quantum fluctuations, like random particles like popping into existence and out of existence, whether that would be, whether that could possibly be explained by particles moving through other dimensions into, say, a plane that we exist in, and if that's impossible, can you explain why?
Not only was that a good question, you're making everyone else in this room feel stupid. I just want you to know, okay? Just so you know. All right, so who wants to volunteer for that one? Katie, you want to hit that? Virtual particles coming in and out. Is that another dimension talking to us?
Well, we definitely know that particles pop in and out of existence. It happens everywhere all the time. And this gets back to this is what people think might be responsible for the dark energy. Only the problem is when you do the calculation, it comes out wrong by 10 to the 120th power, the 120 in the exponent. So in fact, there's much too much of this fluctuation going on in our calculations. So if you're going to include the amount in the other dimensions, it's not going to help. So I don't think that's a very good answer to your question, but this is at the heart of one of the deepest problems in all of physics.
Marcelo,
so not a stupid question.
I just wanted to add that, yes, theories with extra dimensions, when there are certain properties of these extra dimensions that they oscillate in certain ways, they can produce particles in 4 dimensions that we can actually detect, called pyrgons, I think. Sort of an old idea.
Gurdons?
P-Y-R-G-O-N-S, right?
Pyrgons?
Pyrgons.
Gons. That sounds like creatures out of Star Trek or something.
So yes, the presence of extra dimensions creates certain particles in 4 dimensions, or could create. I don't know if they're electrons, but they could be there.
Okay, I think we have the last question here.
Thank you.
Welcome.
This is again touching on mathematics, and the question is, to what extent are our systems of mathematics and measurements subjective or objective, invented or discovered? Gödel, of course, talks about incomplete systems, but Einstein says, as far as the laws of mathematics refer to reality, they are not certain, and as far as they are certain, they do not refer to reality. Any comments?
Yeah, Jana, why don't you take that?
Well,
This is what you've been working on,
well,
which gives you the final comments
I'm
of the
still
evening.
working on it. The interesting thing about Gödel is that he really was a strict Platonist. He actually believed that mathematical forms had concrete objective existence. This world he wasn't so sure about. He wasn't really sure if his ordinary experience was created by his own mind, and he really had breaks with reality, but he did believe in transmigration of the soul and the idea that he would get closer and closer to a Platonic reality where it would all be perfect circles, pi, irrational numbers. And I think it's hard for most of us to follow that particular philosophy. I think that there is no simple answer to whether or not mathematics is the objective reality. I mean, Lee sort of brought up this idea that maybe it's just a description, but one which could never completely encapsulate. Did you say that, or am I projecting? Could never completely encapsulate physical reality. I mean, I think it's difficult to make a philosophical determination. I believe in being a bad philosopher, and at times being a complete objective realist in terms of mathematics when it's convenient, and at times not being. But what seems to be true is that functionally, it's incredibly powerful. Functionally, it continues to work, and so we continue to pursue the ramifications of mathematizing the universe.
I want to live in a world with irrational numbers and rational people. That's what I want to do. Let's end with just, in 10 years, where's string theory going to be, or TOEs? 2021, where is it going to be? We're going to come right on down, and we'll end the evening. Go. But
You
be
know,
quick.
I hope we have a quantum theory of gravity, whether it's string theory or not, and I hope that there is experimental test of it and verification of it. I think it could be one of several approaches, maybe loop quantum gravity, maybe causal dynamical triangulations, and maybe string theory, and we shall see. This is science, which means we don't know the answer.
Will we see it in 10 years?
Yes.
Good. How about you?
I think
2021.
I think it's a great time to be a scientist. We have great experiments on the horizon. We're going to see space ringing in gravitational waves. We have the Large Hadron Collider, and we have great mysteries. We know there are things we don't know. There's dark matter, dark energy. We know we haven't unified all the forces. So we have great mysteries. We have tools to approach those answers. I'm pretty optimistic that some of the pieces of the puzzle are
So
going to
the
fit together.
known unknowns are quite striking. Yeah. Are there any unknown unknowns out here? You wouldn't know, of
You're
course.
confusing me.
Marcelo, 10 years from now,
So
where are we?
yes, I think that at least in 10 years we'll have excellent data to possibly either confirm or rule out supersymmetry, and also know if the Higgs particle, which we also did not mention tonight, exists
That's
or
the
not.
famous God particle giving mass to all the other particles, right?
What it actually used to be called the goddamn particle, because they can't find it. So that's what Leon Lederman, who wrote this book, The God Particle, said. His real title was The Goddamn Particle, but the editor didn't like it.
The editor changed it, yeah.
So anyway, so I'm optimistic in the sense that we'll have the data. I am very skeptical with notions that our ideas, when they go too far, always have something to do with nature. That this sort of extreme Platonism worries me a lot.
All right, Jim, 10 years, where are we?
Well, first of all, Marcelo just actually took my answers. I think in 10
Okay,
years-
should we skip you?
Yes.
That works. No, seriously.
Oh, you're not serious, though. I think that, in my pessimistic moments, I think in 10 years, string theory is not going to be complete. Because what's going to happen is a genius is going to have to appear, and that doesn't occur on anybody's time clock. We actually are going to need...
You're agreeing that the whole community is just not smart enough to figure it out.
No, because such people do appear.
No, but right now, all the people who have been working on it aren't smart enough. That's what you're saying.
No,
What are you
because
saying?
given time, one of them might actually be that genius.
Okay.
So In my darker moments, I think in 10 years, we are not going to have what Lee will probably be happy to hear, which is a background independent description of string theory. I think that's the absolute most important thing to find.
Okay, Katie, 10 years, 2021.
Dark matter, yes. Dark energy, we'll know a little bit more. Higgs, yeah, probably.
Again, the particle that gives mass to all other particles.
The goddamn particle.
The goddamn particle, yeah.
The gravitational waves, good bet. So a lot of the data are going to come roaring in, but is this going to prove or disprove string theory? Probably not.
Okay, just give us a better understanding of the 4% plus the dark matter, not the dark energy.
And the supersymmetry, which is an important ingredient.
Okay,
And possibly the things Lee was talking about, these tensor modes, will tell you perhaps about something coming from the string epoch. So there's some hints there.
Brian, we're giving you the last word here because you had the first word. You're going to close this out. 10 years from
Well,
now, 2021, where are you?
Yeah. Well, look, here's my feeling. I really enjoy these Asimov debates, and to secure my place at the 20th anniversary Asimov debate, I'm going to hold back my answer until then.
Join me in thanking the marvelous panel. '11 Asimov panelists, thank you, one and all. Thank you all for coming. We'll see you again in a year, and we might see you just out in the Hall of Northwest Coast Indians. It's been a great evening. I learned quite a bit, and we will have the panelists there. I also want to just thank a few people. There's Suzanne Morris, who ran this whole thing, made it run as smoothly as these always do, and my assistant, thank you, Suzanne Morris. My assistant, Elizabeth Stachow. And we have a whole slew of volunteers. Collectively, I just want to thank them all for making these evenings run as smoothly as they do. We'll see you again next year, and we might see you again out on the tables.